Hello, thank you for joining. I'm Jake Dickinson with Maxar. I'd like to also welcome John Roos, Maxar's Sales Director for Canada. He will be joining us after the presentation for the Q&A session. Maxar Technologies is a space technology company with over 60 years of industry leadership, headquartered in Westminster, Colorado. Down the road from Denver, which is where I am presenting from today in my home office. I'll start with a little bit about Maxar. So Maxar, we have two major divisions. One is our space division, where teams build and operate satellites. We have over 90 satellites that have been built by Maxar on orbit today for various customers. And then the other division is our Earth Intelligence division, and that is where I work. Our Earth Intelligence division focuses on data, products, services, and solutions, typically geospatially focused, that provide insights to our customers. One of our more well-known assets is our constellation of the highest resolution commercial optical imaging satellites in the world. We currently have 4 very high resolution imaging satellites on orbit. They take over 3 million square kilometers of new images every day. Along with that, we have a 20+ year archive of very high resolution imagery all over the globe, dating back to 1999. In addition to our current constellation, I'm very excited about our new constellation of satellites called Legion. The new Legion class constellation will start launching in 2021. And we're really excited about that. Okay, in this presentation, I'm going to be showing examples from all of our current imaging satellites that are on orbit. All right, let's talk about the presentation. So I'll be showcasing several different areas of interest that relate to Arctic expansion and climate change. Each of these short vignettes highlight different use cases and the value of being able to monitor the Earth where other means are not readily available due to extreme conditions, national security reasons, etc. I'll focus on the 3 main themes I have here. So military and defense related, and the expansion of that. Trade, another key area of focus, including shipping routes and energy exploration, and the impact of climate change on people and the environment. So let's start off with monitoring military and defense expansion. As the Arctic warms, nations have a new strategic focus on the region. The warming has and will continue to open up waterways to shipping and oil and gas exploration, and they're making the Arctic a strategic economic region. Canada's Arctic and Northern Policy Framework has a key goal of ensuring the Canadian Arctic and North and its people are safe, secure, and well defended, outlining enhanced presence and responsibility of the Canadian Armed Forces as well as other agencies. This year, Russia released their basic principles of Russian policy in the Arctic. This policy document also outlines their increased strategic presence in the region. The remaining Arctic nations have released similar policy documents, and it's clear that the need to be able to monitor the region for military and defense purposes will continue to increase. So before I dive into the vignettes, I'd like to mention the tool you'll be seeing in the slides that contains our imagery. So SecureWatch is our cloud-based platform that provides access to Maxar's 20-year, 120 petabyte archive of imagery. I am the product manager for SecureWatch for our defense and intelligence customers. In addition to the Maxar library, all new collects from our constellation are also added to the platform. So I use SecureWatch to discover, display, and exploit all of the imagery that we'll be seeing today. With that, let's get started. So the first example I'll start with will be Severny Klever. Forgive me for any of my pronunciation. A lot of these sites are in Russia, and I do not speak Russian. So this Severny Klever is located on the Kotelny island in Russia. It was originally developed in 1949 as a minor polar airfield during the Soviet era. This base has undergone significant expansion since the new airbase was established in 2013. As you can see in this image from our WorldView 2 satellite taken in 2014, the construction of this section of the base was well underway. You can clearly see shipping containers, vehicle tracks, roads, and the outline of the base beginning to take shape here. This next image was taken June 3rd of 2015 by our WorldView 2 satellite and shows the progress that was made. I understand that Severny Klever is Russian for northern clover or northern shamrock, and by this point you can see that it's clearly taking the base of, or taking the shape of the clover or shamrock. This is a recent image of the now operational base. This is a WorldView 3 image from just a few weeks ago on June 24th. With the 30 centimeter resolution, you can make out clear details that wouldn't be visible in lower resolution imagery. Here we compare them side by side. You can clearly see the progress that was made in just a couple of short years. This example illustrates how we can use very high resolution imagery to monitor construction in an otherwise inaccessible area. All right, this next vignette is of Nagurskoye in Alexandra land, Russia. This is another Arctic airbase in the Russian Federation that has undergone significant expansion in recent years. This is a zoomed out WorldView 3 image from April 19th of this year. For some context, this area on the south, I'll use my pointer here. This area on the south is the coastline. This is the frozen sea. Let's go ahead and forward. So this first green box is the original airfield at the base. You can sort of see the runway underneath. This next green box that I'm showing is the new air base. So you can see that it's clearly plowed. So first we'll go ahead and zoom in on this area, this green circle. This is the area where the tarmac for the airfield is located. We can clearly see that there is an aircraft. This is an Ilyushin 76, an IL-76 cargo aircraft, perhaps having brought supplies or personnel to the airbase. Also in the image you can see that it's clear that a lot of plowing has recently taken place. So this is zoomed in on that previous image we were looking at. Zooming back out, we will take a look at what is called the Arctic trefoil, which is the main living quarters and offices at the base. Here it is circled in green, and we will go ahead and zoom in. This facility appears to be very well maintained and active. You can see why it's called a trefoil. We can clearly see that there are lots of marks where plowing has taken place recently, and then the well-traveled roads as well. All right, now let's go ahead and take a look at a different area of the base. This is a very interesting feature. It looks like there appears to be something causing a plume or scar on the snow and ice. So let's go ahead and zoom in there. And we can see that this is some sort of quarry that is actively being worked. In this image, you can easily and clearly count the trucks. With some skill, volumetrics could also be derived from a high-resolution optical image like this, measuring the volume of material moved and other derivative products as well. All right, the next area we're going to take a look at is this pier on the sea ice over here to the south. In this image from April 19th, we can see the outlines of what appear to be containers or some sort of boxes on the pier. So that image, I'm actually going to go back. That image was taken on April 19th of 2020, so just a few months ago. Just a couple weeks after that, on May 2nd, Worldview 3 was able to image the same pier. And what we have here is the Severny, one of Russia's nuclear-powered icebreakers. As part of President Putin's Arctic strategy, several more icebreakers have been commissioned and more are in production as well. So let's zoom out a little bit on the icebreaker. This is again the image from the second, the one we just were looking at previously. In this image, you can see the path of the ice. So let's use the laser pointer. So you can clearly see that the path is there, and maybe there's some broken ice. It looks like it's starting to freeze back over. And we have some water evident here. So you can clearly see the path that it was taking. All right, so this next image is actually a radar image. Maxar has a partnership with MDA that provides RadarSat-2 imagery over 250 plus areas of interest where our customers can view the imagery within SecureWatch side by side with our optical imagery. Of course, radar imagery can provide valuable supplementary information to our very high resolution optical imagery. Here you can see a RadarSat-2 image from April 23rd, about a week before the icebreaker arrived. So you can see this is the same area. Up here is the pier, and then this is some land over here, but this is mostly part of the sea. Now this is a RadarSat-2 image from May 7th, 5 days after our optical image of the icebreaker. On this image, you can clearly see the reformed ice track from when the icebreaker departed. So that's right here. Due to the all-weather day-night capability of radar, we were able to see through clouds and get more context. So this is a great illustration of how optical imagery and radar imagery can be used together to form a more complete picture of activity. So again, prior to the icebreaker arriving, and this is after the icebreaker has departed. Without even looking at an optical image, you can see that a ship has came and gone. This is that same image from the 7th of May zoomed out, that RadarSat image. And just to give you an idea of what this type of image would look like, you can clearly see the ocean, some ship tracks. It looks like may have done a turnaround of some sort down here. And up here you can even see the airfield as well as the Arctic trefoil. All right, so this last one really focused on how we can see, lots of different contexts from just a few images. This next vignette also focuses on defense and military monitoring. We're going to go ahead and take a look at the Russian aircraft carrier, the Admiral Kuznetsov, in port in Murmansk. So the Admiral Kuznetsov is the flagship of the Russian Navy. It is it's its only operational aircraft carrier. And this image from GOI-1 actually captured this vessel in 2018, showing it in port in Murmansk. It's near its home port, which is Severny, fairly close to the Murmansk pier where this image captured it. And here it is again in March of 2019. So this WorldView 3 image captured it in the same location, but as we can see, it looks to be undergoing some refinishing of the flight deck. In fact, the carrier is doing a complete refit and modernization and is not expected to return to service until 2022. This next image is from a couple weeks ago, so on June 25th, and shows that even more of the flight deck has been removed. In this example, we can see how high-resolution optical imagery can help monitor military assets and of strategic importance. All right, so the next theme I'll discuss is monitoring trade expansion. So with the Arctic warming, there is a great deal of potential and increased shipping routes, oil and natural gas exploration, as well as scientific research in the Arctic. Utilizing the Northern Sea Route and the Northwest Passage can cut travel times between the Pacific and Atlantic Oceans by up to 40%. It is estimated that up to a fifth of the world's undiscovered oil and gas reserves are in the Arctic. So lots of reasons why it is important to continue monitoring the trade expansion in the Arctic region. In our first trade-related example, I'd like to focus on the liquefied natural gas terminal located in Sabetta, Russia. This joint venture between Novatek and the Russian government broke ground in 2012 and provides LNG to both the east and west, utilizing the fleet of icebreakers Russia has in operation. So this exquisite shot of the plant by WorldView 3 was taken last month, showing that the ice remains even into June in this port here. You can see a ship in port, looks to be taking on fuel. This is the pier, and this is the LNG plant. Let's go back a few years. So this shot from WorldView 2 in 2010 of the same area shows just how much progress was made in a few short years. August 18th of 2010. The next image, although it's a pretty cloudy image, we can still see that the plant has had significant progress. So in this area, you can already see the outline. We've also seen some progress on the pier being constructed. Again, this is June of 2014. And a little while later, we have this image. Of course, we have lots and lots of images in between, but just for illustrative purposes, chose a few of my favorites. This WorldView 3 image from 2016 shows significantly more progress. The construction projects in the Arctic typically have extended timelines due to the harsh conditions and impeded access, but we can see they've made significant progress on the pier as well as on the rest of the terminal. Again, this is a mid-June time frame, and we can still see some ice in the image. Pretty harsh environment. And back to our most recent image here, which was taken last month on June 3rd. So this is another example of being able to monitor infrastructure in the highest detail using satellite imagery. All right, our next example here is going to show Russia's first operational floating nuclear power station in Pevek, Russia. This program has been under development since 2000 with the objective to provide power where it is needed, and the first is in the Arctic port of Pevek. So this vessel, I guess we can call it, it's a power station, is named the Academician Lomonosov. It began construction in 2007 and provided heat for the first time just last week. It is reportedly capable of providing up to 70 megawatts of electricity and or up to 300 megawatts of heat. So it's currently providing heat in this port. As we have before, we'll go ahead and take a look at the progress that's been made over the past few years. Here we have a WorldView 2 image from July of 2016 in the same location as before. There is no pier at this point in Pevek. This image is actually from our WorldView 1 satellite, and it shows the initial construction of the pier. The image is black and white because, as many of you probably know, WorldView 1 doesn't collect in color bands. It only collects panchromatic imagery. So the snow and ice in this image make it almost look like a terrain relief model, but it's actually a panchromatic image as displayed in black and white. I wanted at least one example from each of our on-orbit satellites, so this is the one I was excited to select for this. Again, this is 2017. You can see the construction of the pier. And we have another image from 2019 from WorldView 2. This is, of course, we had many images between 2017 and 2019. I chose this image because this is our most recent image prior to the power station arriving in late August. This is the first image we got of the power station, and this is mid-September. It's a WorldView 2 image captured on September 15th. So the power station is at the pier for the first time in this image. And then we zoom all the way forward to just a few days ago, and the power station is currently in a configuration for producing heat for Pevek. Again, this is just another example of being able to monitor activity with satellite imagery that's in an otherwise inaccessible area. All right, so that concludes our trade theme. For our final theme, we're going to talk a little bit about a couple examples that show the impact of Arctic expansion and climate change on people and the environment. High-resolution imagery can help us monitor many of these impacts to the environment and peoples in the Arctic. Although not in the Arctic, I thought we'd start with some imagery over Fort McMurray. As many of you probably know, Fort McMurray had a fairly devastating wildfire in 2016. This subarctic area, on May 3rd of 2016, a fire started. It ended up being one of the most devastating in Canadian history. The fire destroyed approximately 2,400 homes and buildings, and over 80,000 people were evacuated from their homes. So I decided to show you all just one neighborhood in Fort McMurray. This is an image that we captured on May 3rd, which is the day that the fire had started. In this image, the fire had clearly not yet reached this neighborhood, but just 2 days later, we shot this image with Worldview 2. The fire by this time had ripped through the neighborhood, destroying many of the buildings. This is a zoomed out view, so let's go ahead and take a closer look to see what we're seeing. So this is zoomed in. Again, as before, this is the image from the 3rd, prior to the fire arriving. It looks like a pretty tranquil neighborhood. You can see vehicles on the street. And then this next image, unfortunately, 2 days later, shows that most of the buildings in this area have been lost. You still actually even see some vehicles on the street there. So it's pretty sudden. After this image was taken, we were able to publish it through our open data program, Maxar's open data. Previously Digital Globe, but again, we are now Maxar. It helped provide first responders and residents with the most up-to-date information of what was happening on the ground in this area. At this time, the blaze was still ongoing and people were not yet able to return to the area, so this gave an up-to-date picture. And that open data program, it's pretty cool. We provide data for humanitarian relief and assistance for free to the public. All right, we're down to the final vignette. We'll go ahead and take a look at a very recent event. It is the Norilsk Russian oil spill. The spill occurred on May 29th of this year. It's still having a lot of impact on the environment and surrounding area. It's been described as the largest oil spill in modern Russian history. One claim is that the spill was caused when the permafrost under a storage tank softened and the tank supports failed, causing damage resulting in the leak. So let's start with this Worldview 2 image. This is prior to the spill. Again, the spill occurred on the 23rd. I'm sorry, on the 29th. And this image is from the 22nd, a week prior. This next image is from the 6th of June. So we actually didn't image the area right away. I don't know that it was realized to be as big of a spill until after, at least several days after the leak. So here on the 6th of June, you can clearly see the discoloration of the river. Highlight one area. And you can see a couple of these white tarps or tents that are part of the response. So again, we're at a pretty zoomed out level. We'll take a more zoomed in look here in a moment. Just want to give some context. Also, for additional context, this is just one small area. This leak affects, a whole portion of this river. But zooming that far out, you weren't able to see enough detail. So this is that same area, just the following week, and shows a much larger response to the cleanup efforts. This is a very clear image. You can see, even from this zoom level, you can see a lot of vehicle tracks, all the tarps that have been laid out as part of the response. This is a GOI-1 image from June 13th. And then this image, also from our satellite GOI-1, is from just a few days ago on July 3rd. And it shows that the cleanup effort appears to still be underway. We'll go ahead and zoom in. So this green circle is the area we're going to zoom in on. And this is just, again, one of many, many areas on our imagery where we've seen, a lot of evidence of the spill. So we'll start back with the image prior to the spill. Take note that there are no vehicle tracks or marks. Looks pretty pristine here. And then this is the image about a week after the spill. You can clearly see that they have put up booms to help stop the spread of the oil. There's another boom here. We have this giant tarp, which is obviously part of the cleanup effort. You can see some vehicles, containers, and clearly all the vehicle tracks that are starting to be made into this area. So going from the 6th to the 13th, 7 days later, a lot more progress on the cleanup. You can see all the discoloration in this area, a lot more vehicle tracks and many, many more tarps. The booms are still there and discoloration of the river is still there. And finally, this is the final image, and this is just from last week. The river doesn't appear to be as discolored. It's really hard to tell. Still, I'm sure the contamination is there, but the cleanup effort is very much still underway. All right, so these last couple examples have shown how we can monitor the environment in detail, again, in very hard to access areas. For us, with a satellite constellation, it's much easier to get clear images on the ground of what's happening. Okay, so that concludes the presentation portion. Thank you very much for joining. I hope that you enjoyed the beautiful imagery that our satellite constellation has collected for us over the past few years. And we will now have a Q&A session, and we welcome your questions. Again, I'm Jake Dickinson. I also have with me John Roos, Maxar's sales director for Canada. Thank you.
Hi, everybody, and welcome back. So if I could ask our speakers who are joining us to unmute themselves and turn on their video, that would be great.
Hey, Jonathan, thank you. It looks like you might need to actually start my video for me. It's saying the host.
Okay, just a second. There we go.
Okay, well, thank you very much for having us, Jonathan. As I think you're aware, unfortunately, John Roos was not able to join us today. He had a last minute kind of emergency, so we wish him the best. And I think it'll be me, but we did have another Maxar team member that's able to join, so that's Will. Maybe we could.
He should be joining us right there now. So that was a great presentation, Jake. That was a lot of imagery. Obviously, Maxar can just do, state-of-the-art technology, huge market leader, just amazing stuff. We're really glad to have you guys with us as our gold sponsor. We're very sorry John couldn't be with us at last minute change, but we're so pleased that you and the team could be with us. So maybe everybody, the Q&A is open. Put your Q&A questions in the Q&A tool. If you don't mind, wanted to kick us off with a question about how would an organization go about getting access to some of the imagery here? How would we start being able to get some data from Maxar on some of these things?
Great, thanks a lot, Jonathan. And just again, really excited to be here. It was really fun for me to put together all these images. I had never spent a lot of time on the Arctic region, so a lot of these sites were new to me. And it really is just fascinating how much imagery we have and really interesting things, in just the short time that I've had to put this presentation together. So it's been really fun. So to your question, how do you get access? Well, as I mentioned in the presentation, the SecureWatch tool is our primary means to get access. It's a subscription access tool. We do provide evaluation accounts, and probably the best way to get in touch is either message Will or John. So I think the emails are available. So John Roos or Will Bryan. And then another way is through our website, maxar.com. I believe in the upper right hand corner of our website, there's a inquiries button where you can fill out an inquiry, and we'll get you in touch with someone that can set you up with an evaluation account.
Fantastic. We've got our first question from the audience. So I'm just going into the Q&A. I'm going to read it out to make it a little bit easier. The question is from Dennis Haynes. He starts with a congratulations. Satellite optical imagery is great, but the Canadian RadarSat imagery is essential in the Arctic due to frequent cloud coverage as are periods of short daylight. It is great and nice to see that Maxar has a collaborative agreement with MDA to access RadarSat 2 and RCM data to complement and often fill the gaps of the optical satellite imagery in the Arctic. In percentage of time, how often do you have to use RadarSat in the North and High Arctic?
Yeah, that's a really great question. I am a huge fan of RadarSat 2. As I think a lot of folks are aware, MDA originally bought Digital Globe, formed Maxar as a company, and since we've actually, we sold off MDA, so we're now separate companies again. We still do have a very strong partnership with MDA, and luckily we were able to maintain our relationship with SecureWatch, having RadarSat imaging in over 250 different areas of interest. We regularly get RadarSat. I personally use it a lot, especially in these areas with low sunlight, with cloudy weather. The advantage of SAR imagery is day-night all weather, but it really is maximizes value when you can combine it with optical imagery, high resolution. High resolution optical imagery is second to none in being able to do feature identification, feature extraction, especially when you're combining multispectral bands as well. So percentage of time, really hard to say. I think it depends on the area of interest. In some of these North Arctic regions, when you're doing, like you mentioned, environmental monitoring, things like ship detection, SAR is really good. But when you want to be able to identify a specific object, I definitely think that optical is second to none there.
Great. Thank you. We've got another question from the audience. Will Cadell asks, given that the worldviews are typically task satellites, how will Legion data be distributed? I would expect it to be much more of a fire hose of data.
Yeah, that's exactly right, Will. So the SecureWatch product actually is what we call our public archive. So a lot of tasking that is done by Maxar, as well as some customers that do tasking, but choose the model where they allow that imagery to be put in our public archive. We do have a lot of customers that do private tasking. And in some areas of the world, we are, capacity constrained at the moment with our 4-satellite constellation. We are extremely excited about Legion. We've already announced 6 Legion satellites that are going to start launching next year. They are going to be sub 30 centimeter resolution, which is better than our best satellite currently. And we do expect a fire hose of data, and hopefully a lot more of that data will be put into our public archive. A lot more capacity will be available for our customers that do tasking. Couldn't be more excited about it. Couldn't come soon enough.
Great, that's fantastic. We've got another question from the audience from Ali Zaid. In addition to still image satellites, will Maxar develop or is it in the process of developing satellites which will capture high resolution video?
That's a topic I think has been debated for a while. The answer that I align most with is you really dealing with trade-offs when you're talking video. If you're doing something like 24, 30 frame a second video, that is a lot of data. And as we all know, on these optical satellites, there's limited storage, limited bandwidth. And what has really tended to provide the most value is, instead of a video, a multi-view. So if you're taking an image every half second or every second, it still provides the context that you would get out of video. You'd see moving objects, but is far, far less intensive data, helping out on the side of the constraints that we have with onboard storage, bandwidth issues.
Great, thank you. We've got another one from Carmen Finnegan. I think I'll just change this up a little bit. With Maxar ever moving to continuously collecting imagery the way that Landsat series does?
So it's a little different with the very high resolution satellites that we have. It's again a trade-off, as all things are with these types of imaging satellites. Our satellites are not able, because they're more focused, we get much higher resolution, but we aren't able to do the extremely wide swaths that Landsat has. One advantage to our satellites is we are able to take off-nadir imagery, which can provide additional value. Say you're a defense and intelligence customer and you want to look inside of a hangar, you can actually, slew the satellite to take an off-nadir image and get some context that you wouldn't normally be able to do with imagers that are always looking nadir. So I think that combining, also in Secure Watch, we do have Sentinel imagery, so you can combine them. Again, any analyst being able to provide the multi-source, multi-int capabilities is going to give you the best picture of your AOI and be able to help you best solve the problem you're trying to solve. So I do think they complement each other, but no, I don't think that we are going to be doing the same model as Landsat or Sentinel.
Great, thanks. There's another question. In the event of a Russian oil spill, it seems that the permafrost degradation was the primary cause of the breach. Does Maxar have plans to intensify the depth of data in AOIs with a high risk of permafrost degradation, such as around infrastructure lines, or does the responsibility fall more on third parties like government and private entities to better utilize existing data?
I think from the Maxar perspective, we always are trying to do our best to monitor disaster response. We actually have a couple different programs. One is a program called our Open Data Program, where anytime there are natural disasters, including oil spills, we will activate additional tasking from our own tasking sources and provide the imagery. In many cases, for natural disasters, we provide the imagery for free through this Open Data Program to help first responders and help scientists and any other interested parties in doing what's best for the planet. It's part of our mission to do things like that. We also have a program called First Look. It's available in Secure Watch, where we try to provide that imagery almost immediately. And again, it helps us build our own tasking around things like this. As far as the doing in-depth analysis of these, there are other parts of the company. It's not really my my forte with what exactly we're doing for the analysis side, but I know that we do things like that.
Thank you. So we've got a hard stop now to prepare for the next portion of GeoIgnite. I want to thank you, Jake, and thanks, Will, for joining us in case we needed you. Sorry we didn't use you more. Again,
my pleasure.
I want to thank Rachel and John as well on the Maxar team and the fantastic group at Maxar who really have enabled us to put on GeoIgnite this year and bring it online. The theme for this year is leadership in times of disruption, and Maxar has certainly helped to provide that here. So thank you very much.
Thank you very much, Jonathan. It was a pleasure being here.
All right, everybody. We're going to be going to our break. And we will be back in 15 minutes. Check the schedule. I think we've got a couple rooms opening up. All right. Thank you.
Thank you.
Thank you.